So here we're asked to do, whoops. I have no idea what that is. Okay, let me, I don't know. I think I hit a button or something and it decided to give me a, let me just move this over here. What we're being asked to do here, we have the graph, we want the derivative. Okay, so there's different ways to go about this, but we have to remember something or possibly learn it for the first time. I'm not sure how far along you are with that, but do you
She was trying
remember?
to teach it. She was trying to teach it today, but it was like,
It wasn't
I
working
don't
for
know.
you.
It was just
No,
weird.
I hear you. I hear you. So what I'm gonna do is try and make this as painless as I can here. Now, it looks like it's a little bit hard to see, but it looks like, for example, number 8 is a parabola, right? And it looks like
Yes.
it has a vertex at negative, what is that? -1 and 2, -2, something like that. -1 and -2
Yeah.
is the vertex, something like that. So here's the
Yeah.
thing. Here's the thing. What I'm going to do is we're going to do a new share here. And I'm just going to draw, because this is going to pretty much be the same for most parabolas. I'm going to say this. This is my vertex. So my vertex is here, let's say. Now, I'm going to draw this parabola, right? If the Lord is gracious and I get to draw a parabola, there we go. Something along the lines of this thing here, okay? Now, the importance of, this is my function here, okay?
Okay.
This is my function. And I'll write original function, okay? The derivative is another function, okay? So there's another function over here. Derivative function is over here. Now, the mystery is, how do you get the original, the derivative function out of the original, okay? Normally, we're used to moving it. We move it to the left, we move it to the right, we move it up and down, we shrink it, we reflect it, we do those things. But the derivative function is made from, get this, the slopes of the tangent lines at every point of the, oops, of the original function. That's what the
Okay.
derivative function is made from, okay? So what you have to do is ask yourself, now this is not the only way to do it, mind you, okay? But this is how I learned to do it. And it took a while to internalize this into a procedure that actually works. Now, we're going to focus on our X's. And we're going to focus on our, I'm going to call this is going to be our Y, but Y is going to be the slope of our tangent line, okay? So I'm just going to write it like that. Now, let's do this. Let's go and look at our, I think the spotlight will be the easiest way for me to show you this. This point here is -1 for the sake of argument, right?
Okay.
This point here is -1, right? And it has a corresponding point down here, right? Now, what is the slope of the tangent line down here?
0.
0. So we would have a point at, if that's really -1, we would have a point at -1 and 0 on our derivative function over here. You see?
Okay.
All right. Now here's the thing. I'm not going to plot totally specific points at every point because they didn't give us that many. But
Okay.
what can we say about the slopes of our tangent lines? Now remember, we're going to go this way. So we're going to go positive, right? What's happening to our slope? What's happening
Increasing.
to our, right, the slope of the tangent line is increasing, isn't it?
Uh-huh.
Is increasing rapidly here. So if this, like what you can go do, and this is where you want to look at your sheet, because you'll be able to see. You want to find a couple of points on here where you can kind of estimate what you think the slope is, right? So you want to try and estimate the slope. Like down here, it looks like it could be, it's positive. This slope is everywhere positive on this side, right? And this slope is everywhere negative over here, right? So in other words, where's my annotation tool? Okay, so these slopes are positive. This slope is one slope. This slope is a steeper slope, isn't it? It's more positive and it's increasing. Now the slopes on this side, what are they doing? Well, they're slanted the other way. These slopes are negative, right? These are negative slopes. And this slope is a big negative slope, a lesser negative slope. So what this is doing is this is becoming, this is very negative, less negative, 0, slightly positive, more positive, right?
Right.
So let's think about what this means on a graph. If I were to graph this, let's say at 1, right? At 1 here, it's maybe I think the slope is 2. Let's just say, right?
Okay.
And at 2, I think the slope is higher than that. Let's say I think it's 3 or 4, right? So here's the thing. If I start to graph this, function, I have the point -1 and 0. So I'm going through the x-axis at this point where the tangent line is horizontal. Okay? So we learned something important here. Okay? I'm going to write it for you. So when a function has a horizontal tangent line, the graph of the derivative has an x intercept because the slope is 0 at that point, right?
Right. Okay.
Does that make sense? So when I have a horizontal tangent line,
Okay.
right? Remember, the derivative is the slope of the tangent line, and the slope of a horizontal line is 0, right? So if I have a horizontal tangent, my derivative is going to have an x-intercept there. Okay, so I have an x-intercept right here. Now, you have to kind of estimate the slopes, but we're going to see if we can finagle our way into this. So we know we're going to have a graph that crosses the x-axis at this point, all right? And we're going to estimate that that's at 1 over here, the slope is 2. Okay. We're going to estimate that the slope is 2 up there. All right.
Okay.
Now we know that our slope increases. We know that our slope increases as our x's get bigger, right? So we might have a slope up there, right? Something like this. Gee, that's looking awfully familiar, isn't it? That looks like a line to me, doesn't it?
Yeah.
Looks like a line. What happens around -2? Let's look at -2, right? So somewhere here, we're looking at -2, right? Remember, we're not estimating the point. We're estimating what we think the slope is at this point. Okay?
Okay.
We're estimating the slant of this line. Now, let me ask you this question, because we don't have too much that we have to worry about here. We know that we go through the point -1 and 0, right? There's only a few graphs in this bunch down below. There's only a few graphs that even do that. So A is out, right? B would mean that our slope was constant because we have a constant function, which we know we don't have, right?
Right.
So B is out. Now, -1 and 0, it's not here. D is not going through that point either, is it?
No.
E doesn't even look like it's, so we're going to eliminate E and F, right? G again is a constant function, which we know we don't have, because if we had a constant function, then our slope would be the same all the time. And it's not, is it?
No, it's not.
Our slope is not constant, so we're going to get rid of that. And then here, whatever this thinks is doing, this is not it, right? So that leaves us with C.
Okay.
8 matches C, right? Now, I kind of went about that in the process of elimination kind of way. But does that kind of make sense to you, what I did?
Yeah, for the most part.
Okay, so
I'm
here's
just like,
what we're going to do.
Okay.
I'm going to take a screenshot of this.
Okay.
And I'm going to clear the drawings out. Now I want you to go, we're not going to do this in order. I want you to go to 13.
Okay.
Now,
13.
how many horizontal tangent lines? How many horizontal tangent lines does number 13 have?
2. 2.
No. Tell me where they are.
Okay.
Where are they?
-2.
I agree. So there's one here. There's
2.
one there. There's one at 2. I agree here.
And then at 0.
There's a third one here,
Okay.
right? You can have a horizontal tangent line and have it be a minimum, or you can have a horizontal tangent line and have it be a maximum, right?
Okay.
So far, so good. Good job. Now, those horizontal tangent lines on the derivative is a graph of the slopes of the tangent line, and there are 3 places where the tangent line has a slope of 0, right?
Mm-hmm.
So we need to find a graph with 3 x-intercepts that are 0, right?
Mm-hmm.
Is there a graph in this bunch down below that has 3 x-intercepts?
Yeah, H.
Yeah.
Okay.
13 matches H.
Ooh, okay.
Now, that's not the only analysis you have to do,
Okay.
but that's where I would start. That's where I would start. If you have
Okay.
any horizontal tangent lines, identify those, they're going to be x-intercepts.
Okay.
Okay. If you're going from the function to the derivative. All right.
Mm-hmm.
See, that wasn't hard at all, was it?
No, not too bad.
Okay, so now let's do this. Let's look at number 12. I'm going to clear the drawings. What can you tell me about 12?
The graph touches at the origin,
That's true. It goes through the
and then
origin.
it has 2 horizontal asymptotes, or no, tangent
No,
lines. They have
it's
2 horizontal
two
tangent lines.
horizontal. Exactly. Two. Where are they?
Let's see. One of them looks like, is that -3?
-3, maybe.
-3, and then the other one looks like it's like 3, 2.5.
Yeah.
But
So maybe. So we have one that's negative and one that's positive. So
yeah.
we're gonna look for something with 2 x-intercepts. 2
Okay.
x-intercepts here. So which graph has 2 x-intercepts?
Um, let's see. D.
That's right. D is the
Okay.
only thing it could be.
Okay, cool.
You see how easy that is as a way to start?
Yeah.
You see where that's coming from? That's usually not the only analysis, but that's a fundamental analytical point to that.
Okay.
Okay.
All right. It's a cool way to start it.
Now here, and sometimes it's enough. Okay.
Okay.
Now, we did one like this before. Let me, we did one like this before. Look at number 9 here. Okay.
Okay.
This is a line. Okay. This is a line. And you have to kind of estimate the slope of this line. Now, you know how to do that. Okay. It's not a very good quality copy, so it's hard to sort of do what you would normally do, which is either count the slope or plot the points. But I think we can make it work enough to figure out what we're supposed to do, okay? Now, remember when you're looking at a line here, right? That the slope of the line, not the tangent, but the slope of the line always stays the same. That's what makes it a line, right? If the slope is 2, then you go up 2 and over 1, up 2 and over 1. It stays that way the whole time, right?
Okay.
So that slope is constant. Yeah?
Uh-huh.
So what do you think the slope in number 9 is? First of all, let's figure out what we think the points might be. Let's try and
One looks like 1.5.
What was that? 1.5?
One looks like it might be 1.5. Or more like maybe, I don't know, 1.9 or something. Or not
Well,
1.9.
okay, so like 2 and so maybe like let's say like 2 and 1.2 and 1 unit up. 2
Okay.
and 1 unit. And what other point were you using?
It's like
Negative.
a -3?
Okay, so we have 2 and 1 and 0 and -3. We're estimating here. Okay, so we're gonna do, we think that this goes through 2 and 1 and 0, -3. Now, what do you think? How do we get the slope of that line?
Y2 minus Y1
Mhm.
over X2 minus X1.
Okay, so do it for me. Tell me what
Okay.
you get.
So what? -3 minus 1.
Mm-hmm.
So that's -4
Okay.
over 2.
Over, remember 0 minus 2, right?
Oh, -2. So that's 2.
Yes, it's positive 2.
Okay.
Now, that slope is constant, right? That
Uh-huh.
slope is constant. So the derivative of this, if I find a tangent line to this line, it's a line, right? So my tangent line is going to have the same slope that this does, but it's going to be constant. Yeah?
Right.
I mean, how am I going to draw? Think about it. This is a little bit, like I said, this is a little bit hard to grasp at this point, but if I'm going to draw a tangent line, I have to be on the graph. I have to touch it, right? So if I draw here, let's say, right? The slope of my line here is going to be the same as the slope of my line here, right? Which is going to
Right.
happen because this is a line already. It's going to match whatever the slope of this line is. So if you're looking at a line, a linear function like this, the derivative is the slope of whatever this line is.
Okay.
But it's going to be a constant function because this slope stays the same, doesn't it? So here m is, we think m is 2, right?
Right.
So we're going to look for, in our derivative function, we're going to look for a constant function. Remember, constant functions are horizontal, right?
Right.
That goes through the y-axis at 2. So if we look down, let me take my mouse. This has a positive slope. If we scroll down, right? The only thing it could be The only thing number 9 could be is which letter?
Hmm.
Let me make this shrink because it's a little bit, there we go. Okay, so remember,
Okay.
we're looking at the ones below it. We're looking for a constant function, which means we're either looking at B or G.
Or
Which one do we have?
G.
Yeah. So
Okay.
number 9 matches G.
Okay.
Yeah.
Kind of cool. All right.
Now, let me scroll up and take a screenshot of what this actually is. Okay, so 9 is gonna, I'm gonna have to make it smaller so that it fits. Okay, so number 9 is gonna match. So if you remember, this was number 8 was letter C, number 9 is G now, right? We
Mhm.
did 12 and 13, okay? 14, what do you think 14 is gonna do? Now, you don't have to do a huge in-depth analysis here based on what you've already eliminated. What is 14 doing?
Oh, it's constant rate of slope, right? It has a constant rate.
I'm repeat that. I didn't get that.
Oh, sorry. Can you hear me
I can hear you.
better? Okay. It's constant, right?
The slope of the tangent line will be constant,
Okay.
and it will be what?
B,
It will
right?
be negative,
Okay,
right?
negative. That's what it is.
Because
Okay.
of the way the line is going. So yeah,
Okay.
it will have to match letter B.
Okay.
Mm-hmm.
Alrighty.
So the only 2 graphs we haven't done are number 10, 11, and 15. Okay.
Okay.
Now, so number 10, let me get some of the drawings out of the way here. Let me clear this out. All right, let's see. Where do I want to go? I want to erase this. Annotate. That's what I want to do. There it is. I'm going to clear my drawings. So I want to clear. Okay. So let's look at number 10. Number 10. What do we see about number 10 in terms of characteristics? What can we say about number 10?
It has a vertical asymptote of 0.
Right. It has a vertical asymptote at 0. So the slope is undefined at 0.
Right.
The slope of the original function is undefined there. But remember to think about the slopes of the tangent line.
Okay.
So what is the tangent line doing when it's really close to its vertical asymptote, right? What is the tangent line there? The tangent line is very positive, right?
Mm-hmm.
It's getting to be greater. This is an infinite slope. Remember, it's almost like an undefined slope, right? And
Right.
then it's starting to get less and less positive. And as you approach 4, it looks like 4, and you're going out to infinity, this is getting almost flat and going to 0, right? It's not at
Right.
0, it's still growing, but it's getting awfully flat around 4, right? So
Mhm.
around 4, we should have something that gets very nearly flat. And again, this function is always increasing, isn't it?
Right.
This function is always increasing. So I need a function that's always increasing because my tangent line it's an increasing function, right? It's
Mhm.
increasing, 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 increasing. It's just that it's increasing a lot more slowly. So we start increasing really rapidly, right? If this is
Right.
a hill, we're increasing really quickly, like you can hardly climb this hill. You're holding on to the tree, you're holding on to the rope, you're like, pull me out. And then you get up
Right.
here, like, okay, finally, it's this is still steep, but I might be able to live, right? And then it starts to level out a bit and you start to get flatter, but you're still increasing. You're just
Okay.
increasing at a more reasonable grade here, if you will. Does that make sense?
Yeah.
So you need a function, if you're going to match this, you need a function that's always increasing, okay? But you have to
Mhm.
think about the slope too. So the slope of the tangent line roundabout in here is going to be 0, but here these tangent lines, like for example, this tangent line here, this tangent line has a positive slope, right? That tangent line has a positive slope. This one has an almost infinite slope, but this one is 0. Where is your function that's always increasing? Out of the
Sorry.
ones at the bottom.
Oh, out of
Which
the ones that okay. It's
which
like
of
what?
the functions, down here?
Uh-huh.
And remember, this one's out, we already used it. This one's
Right.
out, we already used it. This one's out, this one's out,
B's
and this
out.
one's out.
Yep.
So we've
Okay.
got these 3 left. Which one of these functions, if this function is always increasing, right?
Right. Okay.
Then the and it's going to get close to 0 at 4, right?
Right.
Which one of these is always increasing and close to 0 at 4?
F. Right.
Well,
It's
this function increasing? No, it's this
no.
one.
Okay. Oh.
The
Okay.
tangent lines are always this is very steep, very steep, very steep. These slopes, this is infinite slope, right? So this
Mhm.
function here, if this is, let me come back to it because I know what you're saying. Let me erase this and let me erase this and this. So remember here, let me put this on the whiteboard. I ended because I think you and I are saying the same thing, but in different ways. Okay.
Okay.
So let me go and show you this because I think you're understanding it actually really well right now. This function, let's say I have here's my function, right? And this is my asymptote. Let me, because I don't remember what it looked like because that's just the person that I am. Okay. This is like 4 and 1 here. And I'm asymptotic. So if I do, let's just say, for the sake of example, that we have 4 and 1 here, right? There's a point there. I mean, I'm not too concerned that that's exact, but that's approximately where we are, right? And at
Mhm.
that point, our tangent line is almost horizontal. It's not quite because the function is still increasing. Now, I misspoke a minute ago. Let me tell you why. So here, I am not drawing this well, asymptotic to that, but we have something that looks like this. Now, this function is always increasing. That's true. The derivative is not always increasing, and that's where I made my error. So the function here, the function is always increasing, but levels out rapidly at the top. Okay. It starts with an almost infinite slope. So the slope of the tangent line starts out looking like that almost, right? Looking like this.
Mhm.
And then it starts looking more like this. And then it starts looking more like this. Oops. Starts looking more like this. And then it starts looking almost like this. It's not quite zero, right? But it looks, so this is like zero slope, but not quite zero. This is a little bit more than zero here. That's why it's not an intercept, right? But it gets awfully close. And that happens around x equals 4, we decided, right? So what's happening is this is a very positive slope. These are all positive slopes, aren't they?
Mhm.
This is an almost infinite slope. So this is a huge slope. This is infinite slope right here. And it's very positive, less positive, and less positive still. So what's happening is my slope, as x increases, the slope, and this is where I misspoke. The slope, the function is increasing, but the slope is decreasing. So we need to look for a function because we're looking at the derivative. The original function is always increasing, but the derivative is a function that is decreasing until it becomes almost zero at 4, at about x equals 4, right? The other thing to keep in mind is it's not defined for negative values of x, okay?
Okay.
We don't have any points for negative values of x. So if we go back to our, we have to eliminate the ones that have negative values of x, because guess what? It's not, so we can eliminate a, why? Because it's defined for negative values and we don't have any negative values in number 10. So we can eliminate A and we can eliminate E, which leaves us with F. So this is, let me annotate this. This is F. this number 10 is letter F. This is number 10.
Okay.
This is F. Now looking at, and just to help you, B was, B was, or I mean 8 was C. So this went with number 8. 9 was G. Because it's getting hard to remember which is which. I know that.
I know there's so many of them.
We haven't done 11. 12, we had, remember, we had two horizontal tangent lines. So that was D. Then we have 14. 14 was B here. This was 14. This is B here. And then we had 13 was H. So 13 was H. So here 13 is H. Okay. So now we have these two left. Now think about what's happening to the slope of your tangent line. On number 11, right? This function is always decreasing, right? What's happening to the slope of my tangent line?
Slope of the tangent line.
So what's happening? What's the slope of the tangent right here?
It's decreasing.
Okay, that's true. Well, but is it positive or negative here, the slope of the tangent line? Which way does the tangent line go? Does it go this way or does it go this way?
It goes down. Or well, it goes to the right.
It goes this way, right? So the
Right.
tangent line will have a negative slope, negative slope, negative slope, right? And then it's going to get really close to 0. It's not quite completely flat right here, is it?
No.
But it's awfully close to that. Somewhere between maybe 1.5 and 2. It starts looking like the tangent line's getting very flat around there, right? But this is still decreasing, isn't it?
Yes.
So it's still, I mean, it's still a little bit more than 0, right? It's a little bit more, but it's not quite there. So it's, the slope is negative, 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 negative. Then it gets really close to 0, right? And in here somewhere, it probably does become 0, somewhere here, right? And then it's gonna stay really close to 0. Now now here's the other thing. This function is defined for all reals, it looks like, right? This function is defined for all real numbers. So would we be looking at A or E here? Remember, we start out with a negative slope. So we want to start out with negative numbers. Right. And then we're going to go We're gonna get close to zero around one, and then we're gonna have a zero slope that kind of stays with me for a while. It's gonna be A. This number 11 is gonna be A.
Okay.
Okay. And
Mm-hmm.
that leaves E to match 15, which makes sense because look, E is only defined for values that are less than or equal to 2. And the domain of E
I'm
is,
sorry, did you say something, Shauna? My computer's kind of...
I said number 15 matches letter E because it's defined for values that are less than or equal to 2.
Okay.
Okay?
Okay.
Does that help a little bit?
Yeah. I mean, it makes sense
It
for the
takes a
most
while. It
part.
takes a while to get used to.
Yeah.
It takes a while
It's
to get
definitely,
used to. But
it's
you're
definitely...
graphing the slope of the tangent line.
Okay.
That's what you're doing there.
Okay.
Okay.
Not too
Okay.
bad. Not too bad.
And I took a screenshot of what you see on the screen here. So you
Oh,
can
okay.
go back and study. I cross-referenced it. So like 8 is graph C, and if you go to graph C, it's number 8, so that you can look back and see
Oh, okay. Thank you.
what they are. Okay.
Sounds good.
Anything else?
Let me see. Because that was interesting to me. I was like, what is
Yeah,
that?
no, that takes a minute to figure out.
Okay.
Takes a minute to figure that out for sure.
Let's see. The rest of this kind of made sense. Let me look at tonight's homework. Because there's probably something weird on it.
How'd she do it explaining it?
She showed us, well, she showed it today,
Uh-huh.
and there was 3 graphs,
Uh-huh.
and it was like f of x, f prime, and then it was, I don't know how to say it. It was like f prime prime.
That's
It was like,
called F double prime,
okay, I didn't know,
or
I didn't
the
know what it was.
or the second derivative of F.
Okay, I think she was calling it the second derivative of x.
Yeah, so
Okay.
F prime, we could say it's F prime. That's the first derivative of F. And F double prime is the second derivative of F.
Yeah, and then she was doing it, and then I got confused because she started doing it like because it was in columns, but it said like f of x and then f prime and then f double prime, and then they were in columns, but she was kind of doing them out of order, and I didn't know which ones belonged with which ones.
I see.
And I was like, I don't know what's going on. So, and then today she introduced an equation. She introduced some equations. So let me show you this one.
Yeah, talk to me. It
It
sounds
kind of
like we did a lot today.
Yeah, well, it was weird because like she went over those notes and then
Uh-huh.
she jumped into like some equations and there was like an H and there was like a lot of distributing. And I was like, what is going on?
Does it look like, let me show you this. Let me see if I have, I think I do. Let me see. Difference quotient. Difference quotient right here, maybe. Let's see. Functions, PowerPoints. And usually it shows up in inverse functions, Analyzing graphs. Maybe it's under. I don't have.
Also, I still don't understand. Okay, maybe I'm just like have a really hard time listening. But what is the derivative? Like, is that just slope? That's just slope, right? The fancy word for slope.
Well, okay. Actually, that's a really good question because there's a lot of meanings of derivatives.
Okay, because I got really
There's
confused about
a
that first.
lot of meanings for what the derivative is. Okay. So
Okay.
that's probably why it's confusing to you. Because what it sounds like you've been doing is learning a lot of the applications of derivatives without without knowing what the let me just see if I have, hold on, bear with me for a minute. YouTube Studio. I want to look for my video with Oscar that I did. I don't know if okay, yeah. Let me just, oh, this is not what I wanted to do. It's not the one I wanted. Let me see. Homework help. Representing functions. Squeeze theorems. Derivatives. Show me all of these. Applications of derivative logs. Let me see. Yeah, I think this will help you. I am not going to subject you to this whole video, so don't worry, but I will, this actually might help you to go through this, which I'm
Okay.
gonna preface this before I share this part. I'm gonna drop this in the chat for you to watch. Now, mind you, it's a 2-hour video, okay? Because
Oh yeah.
it was a whole session with somebody, and they were
Okay.
taking business calc, so it's not everything's gonna apply, but this piece will apply, and watching the graph will probably help you to sort of see how, but I'm not expecting you to watch the whole thing. I just want to throw it in the chat really quick. Okay.
Okay.
And I'm going to go over part of it, but I want to answer your question. But I think that will help you with some of it because it does go through some other things too. This is what we call extrema based on first derivatives, which is where you are. I do have some stuff on second derivatives as well. So but let me just throw this in the chat so that if you want to watch part of it later, you can. Like I said, not required, but it may, pick and choose, go through it if you want. Going to, it doesn't want to, there we go. Have to find the chat feature. There it is. Because I had it the window minimized and then I was looking at another screen. There's the video that I did with somebody. Now, as to your question, which actually, like I said, is a really good one. What is the derivative in the first place? Well, it's a lot of things, all right? One of the first things we learned about the derivative is that the derivative is a rate of change at 1 point. 1 point. Remember? So you're looking at a graph, you're looking at the rate of change. The problem here, remember, was that the problem was, how can I find the slope if only 1 point is given? Remember?
Right.
And the way we got around that was the solution for now. It's not the solution that you're going to have later, but the solution for now is you use the slope of the secant line at points that are close to make an estimate. Remember doing that?
Yeah.
We've talked about this repeatedly. So the first thing you did was the derivative is a rate of change at 1 point. That's the first thing
Right.
that you learned. Then we learned about, and we've been talking about this, the derivative is the slope of the tangent line to a graph, which is what we were just doing right now at a point. Okay?
Okay. Yeah.
That's what we were just, I mean, we've done this before too, but that's what we just spent the last however long it's been on doing. This number 2 is more of a graphical interpretation of what this is.
Okay.
And this is one algebraic interpretation of what this is.
Okay.
You okay, Anna? You on tutor, Shauna? Oh,
Sorry about that.
No. He's making sure you're alive. We have to do that on a regular basis. It's okay. So if your interpretation is algebraic, it's the rate of change at a point. If it's graphical, it's the tangent line. Okay?
Okay.
Now there's other things that happen, which is where you're starting to go with this, is derivatives can tell you a bunch of stuff. And this is kind of where you're starting from, okay? And I'm gonna kind of give you, and that's what the video will kind of show you. Don't worry if you don't understand everything about it. Derivatives, okay, so derivatives there are first derivatives, second derivatives, third derivatives, and they tell you different things, okay? So I'm gonna give you a little bit of it's probably a little further than you've been, but it's coming. I'm gonna kind of try and frame this a bit for you, okay? So first derivatives, which is when you take the first derivatives, and this is an application of this. First derivatives, when you're relating to graphing, when we're talking about graphing, okay?
Okay.
When graphing things, will tell you things like, what can you do with a first derivative? Well, you can find extreme points, like maximums and minimums. you can find intervals where the function is increasing. You can find intervals where the function is decreasing. Okay.
Okay.
Those are some things that you can find. Now, in terms of applications of first derivatives, that depends on what field you're in. Okay.
Okay.
If you're in physics, it can be things like velocity. If you're in economics, it can be things like marginal cost. If you're in say sociology, it might be the growth of population over time, something like that. So there's lots of field specific applications that relate to derivatives also. Okay. But
Okay.
right now, I think you're focusing on these three, would be my guess. Okay. Increasing,
Okay.
decreasing. And now I don't know that she's taught you all of that, but that's that's what typically, that's where we're driving the bus. Okay. Now the second derivatives, the second derivatives, which are the derivatives of the first derivative. Okay. When graphing again, when graphing, we'll give you things like, and we talked a little bit about, you can also use second derivatives to find extreme points. And there are some times when this is preferable to doing it with the first derivative, even though you can do it either way. All right, so you can do this either way many times, but not always. You can find what we call concavity, which you asked me about last time, remember?
Right.
Concavity, which is the spilling water, right? The spilling water or the holding water idea, right?
Right.
And what we call inflection points, which are places where concavity changes. Okay, those are typically what we use derivatives for. There are other interpretations of derivatives, okay, but these are the two that you've been focused on.
Okay.
Okay, so if it's algebraic, then it's a rate of change, and it's a function. Remember that the derivative is a function itself. Okay, so if it's graphing, then you have a graphical interpretation, and it's made up of the slope of the tangent line at a point. Okay.
Okay.
Does that help a little bit more?
Yeah. It helps clarify it.
It looks like a lot of words, but this is just like the menu. Like, this is what's coming up. I'm sure you've heard a lot of these things already. Okay.
Yeah.
But this is kind of where where this ultimately is going is what we call graphical analysis, where either they'll give you an equation and they'll be like, okay, analyze the heck out of this function and graph it using calculus. Or they'll give you a graph and they'll say, all right, tell me about what this is using calculus that way. So you're headed to that.
Okay.
Okay.
Uh-huh.
Let me go and look at your homework, because you said you sent me a an email, right?
Yes.
So let me okay, so it says find the limit f of x plus h minus f of x over h for the functions given below. Write the equation to the tangent line at, oh wow. Yeah, these take some time. This is extremely algebraic. So, yeah. So what, this is mostly all algebra. Remember I said, I don't know if you remember in our last tutoring session, f of x is 7 minus, this is 7 minus 3x minus x squared. 7 minus 3x minus x squared at the point, what value of x was given to you? It doesn't tell you. Number 1 doesn't give you a point, okay? Number 1 and number 3 don't give you, oh, it does. It gives it to you down below in number 2. All right, at x equals 1, okay. So, yeah, well, this is gonna involve a lot of algebra, okay? A lot of algebra. So I'm gonna see what I can do here. This is a little bit hard to put on the whiteboard, but we're gonna see what we can do here. This is gonna take, and I think I'm gonna end up writing it out at some point, but let me just show you this. So, share screen. I need to find that example where I did the difference quotient for you so you can reference that. But you have this function here. It's f of x is equal to 7 minus 3x minus x squared. Okay. And I'm going to write it like this. This gets to be a bear to type, but we're going to see what we can do. Now we're going to use the difference quotient, what's called the difference quotient. And the difference quotient is basically the slope, okay? It's basically a slope calculation. And the difference quotient is f of x plus h minus f of x over h. Okay, now I promise you this part is all algebra. Okay, so there's a ton of algebra involved in this, and the calculus comes at the end. And then we have a little bit of algebra. So we have a ton of algebra, a little bit of calculus, and then we have a lot more algebra to do. Okay, so we have, so what we want to do here is we want to find the, basically we're looking for the derivative of this using the limit of the difference quotient. Okay. So what we're going to do is on every line, you have to write the limit as, let me come back to this for a minute. We need to come back to the homework here. That's why there's only like 9 problems on this homework, because this is like a lot of work. So here, the limit as h goes to 0. So we're going to write this. We're going to say limit as h goes to 0 of, now, here's how this works. This piece f of x plus h messes everybody up when you have a polynomial like this.
Okay.
The way that we do it, and the way that I would suggest that you do it, is that you, everywhere you see x, you put a parenthesis.
Hi, funny bunny.
Hold on, Shauna.
Hey, Gloria.
Hey, what's up, Shauna?
Derivatives,
kid?
Gloria. We're
What's
doing
up?
derivatives, Gloria.
What's that? Derivatives.
Derivatives.
Ew. Sounds hard.
You don't even know.
PIMDAS. Derivatives.
PEMDAS.
Please excuse my dear Aunt Sally.
Well,
I know that.
we get to PEMDAS too, but we have to get through
Really?
a bunch
It
of
gets that
other
bad?
stuff first before we get to that.
That's the easy stuff.
Mhm.
PEMDAS is the easy stuff.
Shauna needs to teach me ratios and portions. Tell her. Ratios and portions, Shauna.
That's just a
I
fraction.
can hear you, Gloria.
Two
I
cups
can
of
hear
cups of
you.
water, one rice. 1 cup of rice. She has to teach me that. I don't get that. I don't get the fractions. I don't get that. Okay, keep working.
We'll talk, Gloria.
All right. Okay.
On days like this, Hannah, I feel like I'm stealing your family. Like,
Huh?
I'm stealing you from your family, you know?
Oh, nah, don't worry about it. It's okay. They get me all the rest of the 24 hours.
So here's what this is. You see what I did here?
Yeah,
I put x plus h everywhere there, right?
right.
Now I have to subtract f of x. Well, f of x is this function. So notice what I'm going to do. I have a minus here, right?
Uh-huh.
And I have 7 minus 3x minus x squared. Are you okay with this part so far?
Yes.
Because this part, if you don't understand this part, bad things will happen to you. Okay?
Anymore. I don't look what you did this morning.
Oh, wait, hold on. Let me ask a question. Wait.
Yeah.
I'm not talking to you, mother. My mother thinks I'm talking to her. So she's like, I don't have any time to answer your questions. I'm like, I'm not asking you.
She's
Okay.
asking me, Mom. It's fine.
I know. She's trying to steal the show over here. Okay, so what you did was, now I'm a little confused. Did you just,
Okay, let me come over here. This is our difference quotient, right?
okay,
Let me do something here. Let me get rid of this. Whoops. Let me get rid of that. Come over here for a minute. So my function is f of x is 7 minus 3x minus x squared, okay? And my difference quotient has a couple of parts to it. We're going to forget about the limit for right now, okay? If I just add, now this is algebraic. If I asked you to find, not find, but write an expression for f of x plus h, what would you write? Don't simplify it. What would the expression be?
7 minus 3x minus x squared plus h.
No.
Oops.
7 minus. Now, here's what you do. Everywhere you see x, okay,
Okay.
I want you to put parentheses here.
Okay.
So it's going to look like this. Squared. Okay?
Okay.
Now, you see where those parentheses are? What's in the parenthesis over here?
X plus H.
So I want you to write X plus H in
Okay.
there.
Okay.
You see?
Mm-hmm.
Now, this piece, if I go back a whiteboard here, see that?
Okay.
This piece is f of x plus h
Okay.
minus f of x, which is this,
Okay.
right?
Got it.
There's f of x over h.
Okay.
Limit as h goes to 0. So far, so good?
Uh-huh.
Now, we get to do a whole bunch of algebra to
Yay!
simplify all of this.
Oh,
Simplify all this. A bunch of stuff is going to cancel. Then we're going to end up with a limit, and we might have to factor to get, but we have to evaluate the limit. Okay?
okay.
But from here, this part is all algebra. In theory, we should be able to do that algebra. Okay?
Okay.
In theory.
In theory.
Let's see what happens. All right, so we have the limit as h goes to 0. Now,
Okay.
we're going to take this really slowly. So we're going to have 7. I'm going to draw a big old line down here, first of all. I need a big line because there's going to be a lot of terms. Because I'm going to be typing it too, so I don't know how long it's going to take to. I'm going to draw that line and call that long enough. This is 7. This is not so bad. What happens to this piece?
You distribute it into X plus H, right? So that's minus 3X minus 3H.
Okay, that wasn't hard. We can do that.
Not too bad. Not too
Now,
bad.
when we get to this part,
Okay.
we have a little bit of a something, right?
Right, because
We
it's
have a
squared.
minus, right? Now I'm gonna write it like this. I'm gonna write it like this so that you can see it. Not that it's some people can do this in their heads at this step. If you can't, don't worry, you can do it on paper, but this is this, okay? The important thing to know is that you have to take the negative through it. Usually people find it easier to, this is where PEMDAS comes in, multiply these out first and then distribute this negative. But you can distribute this negative through this x plus h and then FOIL. But
Okay.
it's usually easier to FOIL the two that are in parentheses and then take the negative through there. Okay?
Okay.
Now, this other piece is also pretty easy because notice the square is on the inside. So we're going to have minus 7 plus 3x plus x squared. Okay? Are you
Okay.
with me there?
Yes.
Okay. So now this is over h. Right?
Okay.
Now, usually, like I said, what most people do is they go ahead and do this and write this whole thing out as a step. I'm not as concerned with how you handle that algebra right now. as
Okay.
that you do it. Like, just make sure you know how it's done, right?
Yeah.
So here, there's a lot of writing and rewriting here. 7 minus 3x minus 3h. Now, let's continue. Minus, and I'm going to use brackets so we can FOIL here. Now, this is x times x, that's what?
X squared.
Okay, that's not hard so far. That's x squared, right? What happens with the middle terms here?
Don't they end up canceling?
Not here.
Okay.
Not here, because this minus comes afterward, right? So think of FOILing x times x is x squared. They cancel if there's an opposite sign. These are the same sign. So this
Okay.
is h times x, which is
HX.
hx or xh, but I'll write hx for this. Then
Then it's plus HX plus H squared.
okay, so this becomes hx, and this is h squared, right? Now, so that's my FOIL, that's my square, right? This is
Right.
my bracket for this term. So there's my bracket, and then I have minus 7 plus 3x plus x squared. Okay,
Okay.
squared. Do you see that?
Yes.
Now we're going to divide that by h. Okay, whoops. I have to make it longer. This way. Okay. Are you good so far?
Yeah.
All right, so now we're going to do some more algebra
Whoop,
to
whoop.
simplify this beast. Limit as h goes to 0. And we're gonna do some distributing, some canceling. This is actually where it gets to be a little bit fun, but you have to be careful here. Minus
Okay.
3x, 3h, minus x squared. Now, usually, I can skip a little bit of a step here. This hx and this hx are 2hx. Would you agree with that?
Yes. Yeah.
So I'm going to go ahead and write this as minus 2hx, just to save space. Can I do that?
Yeah.
And notice that I took the negative through it. You see that?
Yes.
So minus x squared minus hx minus hx minus h squared. You see that? This is
Mhm.
h squared. H squared. Now I'm going to copy. So this is minus 7 plus 3x plus x squared. Okay. Notice that I didn't change any of those signs because there was no negative in front of this parenthesis. So I just copied this. The negative that I distributed was this one. You see?
Okay.
Okay. Now we're all over H. Okay, there we are
Okay.
over H. Now we got a bunch of stuff that's going to cancel out. You see it? This
Yeah.
7 here is gonna cancel with this -7 there.
Then 3x cancel.
The -3x cancels with +3x here. The -x squared cancels with +x squared here.
Okay.
Follow? So this got a lot shorter very suddenly, right?
Right.
Now I'm gonna come up here and I'm gonna say limit as h goes to 0. And I'm gonna say that this is yeah. What do I have left? Well, I have -3h, -3h
-3h.
right here, -3h.
Oh,
see
okay.
it?
Sorry. It was hidden.
Minus 2hx. No, I hear you. 2hx. And then I have minus h squared. H squared over h. Are you with me here?
Yes.
Okay, so now h squared over h. Now I want to find the limit of this. I want
Okay.
to find the limit of this. Now, if I don't know if we kind of talked about this, but it's been a minute. Okay. One of the ways we find limits is with direct substitution, isn't it?
Uh-huh.
We put the 0 in here, we put the 0 in here, we find the limit. If we do that here, is that possible?
No,
Why not?
because 0 will be in your denominator, which is undefined.
Right, but there's a way around it. Notice,
Can you pull out h?
That's exactly what we're going to do. We're going to pull out h. So we're going to say the limit as h goes to 0 of, and we're going to pull out h from the top. Now I'm going to pull out a negative h so that I don't have a negative on the inside of the parenthesis, okay?
Okay.
So I'm going to pull out a negative h. That's going to give me 3 here. That's going to cause a sign change in the second term. You see that? Because I'm pulling out a
Yeah.
negative h. So what is my second term going to be inside?
2x.
2x. Very good.
2x.
And this last one?
It'll be
Mine. It's
1,
going to be,
right?
it's going to be positive, right?
Positive.
Positive h. Good. Positive h. And we're going to divide by h, aren't we? We're going to divide by h, right?
Yeah.
Now, what's nice is this. Watch this. These h's cancel. See that?
Uh-huh.
Now we have this. We have the limit as h goes to 0. Now we still have a negative, remember? So this is like
Right.
-1, which I'll go ahead and write just for the sake of clarity. -1 times 3 plus 2x plus h. Now can I find the limit?
Yeah.
How do I do it?
Just plug in h, right?
Not h.
I mean,
Don't
sorry, 0.
0. Now, this is where sometimes students get stuck. They plug in 0, but they plug in 0 for x. Don't do that.
Okay.
H is approaching 0. So here, substitute 0. Substitute 0 for h. All right. So here you get, now at this point, I'm going to drop the limit because I'm evaluating it.
Okay.
Evaluating this limit. So I'm going to drop the limit in the front. And this is going to be -1 times, and I'll use a bracket just for visual. So 3, there's no variable attached. That's still 3, right? Plus 2x. And I'm substituting 0 for h. So I get this. Okay.
Okay.
Now, what does that mean? That means that this, now remember, I have to take the -1 through it, right? So this is going to be -3 minus 2x. You see that?
Mm-hmm.
That is what we call f prime of x. F prime of x, what you just used was you used the definition of a limit, or you use the limit of, we say, here's how you impress your friends. I use the limit of the difference quotient.
Oh my goodness.
The limit, right? Here's the limit of, oh, I think I removed it. The limit of the difference quotient, but this thing, oops. This thing is called the, oh, I put it over here. This thing here with the h under it is called the difference quotient.
Okay.
So you use the limit of the difference quotient. So f prime of x here is -3 minus 2x. Okay?
Okay.
That's number 1.
Okay.
That's
Wow.
number 1. Okay?
That's a lot. Okay.
But notice how there wasn't much calculus, was there?
No, not really. Not too bad.
And I should have had an x squared here.
Okay.
This is Mr. Gus square.
Oh,
So
yeah.
stick it in.
Hey,
Maybe.
Shauna, I just want to make sure that you didn't have a client at 6.
No, not today.
Oh, okay. So I
Not
remember
today.
saying on Sunday that you had a client.
Not today, but no, he can't come until later in the week. But thank you for
Oh, okay.
asking.
Yeah, I didn't want I wanted to make sure.
No, I appreciate it. I appreciate you asking me, but no.
All right, that's good.
So -3 minus 2x is my derivative. Now, we know that the derivative represents the slope of the tangent line, right?
Right.
We went through this. That was what our first hour was on. So this now is a general expression. Remember I said the derivative is another function, right? Remember that? So this
Yes.
was my original function. This is my derivative now, right? And this
Uh-huh.
derivative is, this represents an expression for the slope of my tangent line at any x. Right?
Right.
That makes sense?
Yeah,
Kinda.
kind of.
Now that's question 1. Now it asks you to find, question 2 asks you to find the equation of the tangent line. Okay?
Okay.
And I kind of did this for you in our lesson online. I wanted you to see where, remember I told you I thought this is where it was going? You have
Yeah.
now arrived. Okay?
All
So
right.
let me show you something. 7 minus 3x minus x squared. Here's the, let me go ahead and show you this. So this, let me stop sharing for a second. And let me go to Desmos, because I want to show you something. We're going to do the second part. And I think it'll help put it together for you. So if I do y is 7 minus 3x minus x squared, right? Now I'm going to have to pull out, I'm going to put this up on the screen. I just want to graph it really quick. Okay, I'm going to put this on the screen. So here, okay, I remember that. You don't have to tell me that. But I do want to share the screen. Thank you very much. All right, so I'm here, right? There's my graph. Okay.
Okay.
Now it's asking me in one of these. I'm gonna have to stop and go back to this for a minute. It's asking me to find in number 2, it's asking me to find the equation of the tangent line at x equals 1. So what it's asking me to do is take my results and okay, I don't have Desmos on this screen, so I have to go back to the other tab and share from there. So here's my, okay, so you should be able to see my Desmos screen, right?
Mm-hmm.
Now from what we did earlier, we know that f prime of x from what we just did is equal to -3 minus 2x. Okay? That's what
Okay.
we just figured out with the difference quotient. That represents an expression for the slope of my tangent line, right? So I want to find the equation of my tangent line when x equals 1, right?
Uh-huh.
Now, if I just have the equation in front of me and I want to find the equation of the tangent line at x equals 1, I'm missing something. I'm missing a little something, something, aren't I?
Yes.
What am I missing here? Do I know where that point is?
No.
If I'm looking at the graph, I might be able to figure it out, right?
Right.
But I'd really like to know where that is, right? It's probably it's probably 1, 3, based on what I'm looking at right here. 1,
Okay.
3, right?
Right.
I was able to figure that out by looking at the graph, right? But you don't want to have to, and what if it's not exact every time? How can you do this algebraically? How can you figure out where that is? Not a hard question. How would I figure out where this point is?
Just plugging in.
Yeah, plug
Points,
it
right?
into there. So here's what you're gonna do. The reason I wanted you to see this first is this. We're looking for a tangent line. Okay.
Okay.
So we're looking for the equation of this tangent line here. We're looking for the equation of that tangent line through that point.
Okay.
Okay. We don't know
Okay.
what it is yet. We know it goes through 1, now 1, 3. We're going to do it algebraically. And we know what the slope is. Okay. So
Okay.
we're looking for the equation of this tangent line.
Okay.
All right.
Yeah.
Does that kind of make sense?
Yes.
Are you sure?
Yes.
So let's go back to the whiteboard here. And let's get a
Okay.
new whiteboard. Now, this is problem 2. Okay. We're going to use the result of question 1. Okay. And remember that was, let's recap. So my function f of x is 7 minus 3x minus x squared. Okay, that's my function. And what step 1 told me was that f prime of x was equal to -3 minus 2x. That's what question 1 said. This was the
Okay.
result of question 1. Okay?
Okay.
Now, question 2 is find the equation of the tangent line to f of x at x equals 1. Okay?
Okay.
Whenever you want to find the equation to any line, a tangent line, a secant line, whatever it is, you need 2 things. You need a point on the line and you need the slope. Okay?
Okay.
So, and that's just an algebraic idea. So to find the slope of a line, any line, at any time, 24/7, 365, you need slope and a point on the line. Okay? Now, sometimes they give you 2 points on the line. Then you get the slope and then you use the point on the line to help you. But you need these 2 things. Okay? Now, here's what we have so far. We know that x is equal to 1 and we have the function. We don't have, sometimes they'll give you an ordered pair. Here, they give you half of an ordered pair.
Okay.
They don't give you the other piece of it. Why not? Well, as you said, all I do is plug it in to that,
Right.
right? So I'm going to write this as 1 f of 1. I'm just going to plug that in there. And then we're gonna get the result from it. That's just a little bit of arithmetic. That's not so hard to do. So this is 1.
Okay.
Do you need me to do the arithmetic or can you?
No.
Okay, so what is the result?
Uh,
What's this for you or for what is this for?
oh, did,
F of 1.
okay, so 7 minus 3 minus 1, so that's
Yeah,
3.
What should you do with it?
that's right. So F of 1 is what you did was you plugged it in here. 7 minus 3 times 1 minus 1 squared. Okay,
Sorry, Miss.
you with me?
Yeah, sorry, Shauna.
You're fine. That's no problem. You're a little bit distracted, but you're doing great. This is 1, 3, okay?
Okay.
Now that's my point. I need also the slope, don't I? Where am I
Yes.
gonna get the slope from?
Can you get it also from the equation?
Which equation?
Oh my gosh, there's a lot of equations.
You're fine, you're there. I'm looking for the equation of my tangent line.
Okay.
So I'm looking for an equation that's gonna give me the slope of my tangent line.
Okay. Well, it would be 7 minus 3x minus x squared, right?
Not this one.
Okay.
Which equation gives me,
Oh, the f prime, right?
yeah, remember this?
Yeah.
This
Yeah.
represents an expression for the slope of my tangent line. So once you do this derivative thing here, right? If they give you a point, okay, plug the x of that point into here.
Okay.
And that will give you the slope of your tangent line. Okay?
Mm-hmm.
So let's continue here. So now we know we're going to get, so here's the point on my line. I know the point, this is a point on my tangent line. Point on the tangent line, as well as a point on the original graph. So it's shared by both, right? And it should be because it's where they're touching, right?
Mm-hmm.
So there's your point. Now your slope of your tangent line, slope of the tangent line at x equals 1 is going to be f prime of 1, which is going to equal what? Well, that's -3. Well, let me back up. F prime of x is equal to -3 minus 2x. And so f prime of 1 f prime of 1 is going to give me -3 minus 2 times 1. See that?
Mm-hmm.
And what does that equal?
-5.
Now remember I said there was going to be a little bit of, so we did a whole lot of algebra with the difference quotient, a little
Mm-hmm.
bit of calculus when we took the limits, right?
Right.
Then we did a whole bunch, there's more algebra here, right? We're still doing some algebra. This is -5 now. Now we're going to do some algebra to finish this.
Okay.
Okay, this is the end of our calculus. We don't have
Okay.
any more calculus here. So now my question essentially is find the equation of the line with passing through 1, 3 with slope m of the tangent line equal to -5. Right?
Right.
So what are we gonna do? We're gonna use, you can use either one, but you said she's been using point slope, so I'm gonna use that. I'm gonna write m of the tangent to remind you that it's the tangent slope and not the slope of the original, but you don't have to do that. This is, now, what is my point?
1, 3, so 1 and 3, so that's what? 1 minus 3
Y minus 3.
equals -5,
Uh-huh.
parenthesis, x minus 1.
Mm-hmm. Yeah. Now, if you want to write it, if you want to change form, you can. So this is y minus 3 equals -5x plus 5. Right?
Yep.
Then if I move the 3 over, I get y equals -5x plus 8.
Okay.
And this is the equation of my tangent line
Okay.
at x equals 1. Now, I'm going to have different equations at different points. But this is the equation at x equals 1. So if I go back and show you here, this is y equals -5x plus 8. Let me change colors. Change this to black. That's your tangent line at that point.
Okay.
You see it?
Mm-hmm. Okay.
That's what we're doing. So the first part, the evaluating the difference quotient and getting the limits, that's giving you an expression for the slope. Okay? The second part gives you a point. You plug in that x to get your actual number for the slope.
Got it.
And then you use that number for the slope and the point they've given you, and you might have to plug that goes into the original function to
Okay.
get the second y coordinate so that you can write your equation.
Okay.
Okay?
Mm-hmm. Sounds good. Okay.
Does that kind of help you see where you're going?
Yeah, it does.
That's
Yeah,
a
it does.
lot of material. But
It
those
is a
are
lot.
the first two. Okay?
Okay. Sounds good. Okay.
What
Whew.
changes with the rest of those problems is the algebra that you have to do to get the difference quotient to work.
Okay.
Okay, so like the algebra in number let me scroll up. The algebra in number 3, because you have a root function you're gonna have to use conjugates to eliminate the radicals.
That's when you do radical 2 plus x, right?
Well, you're just gonna rationalize it. So it's gonna be radical 2 minus x. You're not gonna have two radicals. But you're gonna get rid of the radical, but you're gonna have two radicals at the top. So you're gonna have like
Okay.
2 minus x and minus something else.
Uh-huh.
So the algebra here is a little more challenging.
Okay.
Try it. If you can't get it, text me and I'll send it back to you.
Okay.
But that's the idea behind it. Okay.
Okay.
This one, again, this is going to involve a different kind of algebra. This is going to involve simplifying a complex fraction in number 5.
Okay.
So the algebra of it is going to be different. You know what I mean?
Yeah.
The calculus isn't going to be any different. The algebra is going to be more challenging to you.
More pain in the butt.
Okay. But that's the process of it. Use the
Okay.
difference quotient to find the expression for the slope. Plug in the x to your original function to find the y value.
Okay.
Plug the x value into your derivative, which is the result of what you get from your difference quotient. And then use that result and your point to get the slope of the tangent line.
Okay.
Okay?
Uh-huh.
I'm gonna go, what I'm gonna do before I leave you, I'm going to send you, let's see. I need to stop the recording. I'm going